So far, we've looked at the difference between relational database management systems and other forms of database management in a very abstract way. In this movie, we're going to take a look at the reality of how this works and how our databases are structured. We're just going to be looking at the absolute basics here. We'll get into more details as we progress through this course. Here is one of the most basic units of a database. That is a table. This whole thing is known as a table, and the table's name is groups. Within the table, data is stored according to different kinds of data types, such as we may have a numeric data type or an alphanumeric data type. And what we want is for each record within the table to be similar so that all entries can be treated in a similar way. This is why we've split the table into columns. This is a column. The column's name is ID, and within mysql our way of referring to the ID column of the groups table is groups.id. But never mind the technicalities for now, we're just looking at the general concepts. Here's another column. All the data within the table is stored within a column, and the column name is up the top there, name, groups.name to be precise, and this column stores the name of some of my favorite bands. We're going to use this table in conjunction with another table to access information about my music collection. A very simple database application. These are known as rows. Now, different database management systems will have different jargon connected with them. A long time ago, columns were known as fields and rows were known as records. For the sake of consistency, all the way through this course, I'm going to be calling them columns and rows. A row is a distinct unit of data. So each row is an entry within our table. Now let's take a look at the other table that we're going to be using in our hypothetical database application. This table is the songs table and is set up in a very similar way to the groups table. It has a unique ID column, it has the song title column, and it has another column called group, and we'll explain the reason for this in a second. Let's get these to the same size, and you'll notice that the numbers within the group column match up to the numbers in the ID column of the groups table. This is a way of forming a relationship between the songs table and the groups table. This allows us to avoid storing information more than once. So for instance, Still Number One, My Philosophy and Sound of the Police are all tracks by Boogie Down Productions, but there's no need for us to store the name of the group 3 times, or however many times we have songs within the songs table. That is redundant and can cause all kinds of errors, as we saw in the last movie with the misspelling of the name. And furthermore, if we realized that we had misspelt Boogie Down Productions, or we wanted to change that piece of data for whatever reason, all we'd have to do under this system would be to change the name in the groups table, and then when we came to pull data out about the songs, the group column would refer us to the entry in the groups table, and essentially the data would be corrected for all the songs in effect. This kind of relationship we're looking at here between the songs and the groups tables is known as a one-to-many relationship. This is how we write it in, if we were going to draw up an official database diagram. This is not in any way a well-formed database diagram, simply a simple way of representing some data. But n to 1 or 1 to n meaning an indefinite number, and 1 meaning only one entry. So in this case, each one group may produce many songs, but songs are only written by one group. Of course, there are limitations to this model, and if I was really applying this to my music collection, I'd find that there are a lot of collaborative tracks which would require me to use a more complex relationship known as a many-to-many relationship. However, for the sake of our example, this is a simple one-to-many relationship which links these two tables. Now that we're looking at relationships, I can introduce another very important concept about the database structure, and that is keys. Some columns within our tables are known as keys. These two, for instance, the ID columns in both tables, are the primary keys, which essentially provide a unique identifier by which we can identify each entry within the table. So instead of having to say A Tribe Called Quest, we can just say groups ID 1. This means that when we go to, for instance, make a relationship between the two tables, we don't have to use fallible data such as typing in the full name of the band. For instance, it's not even a question of spelling mistakes necessarily, but someone might simply type in tribe, someone might type in all lowercase, someone else might capitalize the first letter but not the rest. We get rid of all these complications by using a simple numeric primary key. The other kind of key is the foreign key. The reason it's called a foreign key is because it refers to a unique entry within a different table than the table in which the foreign key is installed. In this case, the foreign key is within the songs table, but the data refers to the ID of the entries within the groups table. So the data within the groups column, for instance, on the first row here, Jan on it, we'll look at that. The group is 4, so a quick scan down our groups table will find group ID number 4 is nucleus. So the computer is able to quickly and efficiently locate the relevant group for the song. With regard to foreign keys, I should say here that MySQL does not support the official implementation of foreign keys. That is to say, although we can include foreign keys within our specifications for creating a table, for instance, it won't actually do anything. Other database management systems will only allow us to enter data into a foreign key column when entries exist within the other table. So, for instance, if we tried to add in a new song and we tried to put the number 6 within the group column as an entry, it wouldn't allow us to do that within a different database system. MySQL, however, does not support foreign keys in this sense and is not quite so strict about it. This is a limitation in the way that MySQL implements the relational database management system model. However, there is always a trade-off with these things. With MySQL, you get a significant performance boost because MySQL is not worrying about enforcing referential integrity, controlling cascading updates and deletes, and so on. However, again, the trade-off for that is extra programming work when we come to administer our databases. So there's plus and minuses to this kind of peculiarity of MySQL's implementation of the relational database management system. The way in which we get data from our tables is we have to write a query, and that's where structured query language comes in, or SQL. SQL is a very easy programming language. It's what's known as a fourth generation language, which means it'll be a lot easier than any programming language you've encountered otherwise, very likely. For instance, if you've used C, or if you've used PHP, or if you've used even very simple languages such as GW Basic or Visual Basic, you'll find SQL absolutely, essentially very easy to pick up. And even if you haven't ever programmed before, you'll find that because structured query language closely follows the syntax of real English, you'll find it very easy to pick up. Here's an example of an SQL statement. Now you may look at this and notice some words capitalized, some words not, and say, how can he possibly say this is easy? This is very obscure syntax. But we're going to be looking at what each of these words mean over the course of the next few chapters. And we're going to see exactly what this query can do. This kind of SQL statement will become very familiar to you through using this course. You'll find that you'll pick it up very easily, and you'll find that SQL is a very powerful way and a very flexible way to query your data and administer changes to your data and to pull out specific kinds of data using a query. For instance, this query, put into even more plain English than it is already, simply pulls all the song titles where the song has been written by EPMD. If you take a look closely at the SQL query, you'll see that it's not so far removed from the way we phrase things in real spoken English. However, we'll be looking at SQL in much greater detail in the following chapters.